Hello, 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 and welcome. Let me tilt this down and tilt this over. There we go. Hey, hello, and welcome to Math Today, Tuesday, November 3rd. We are comparing decimals today, continuing our intro through what a decimal is and how it functions in our place value system. And then we're going to be using our greater than and less than and equal signs to compare some decimals. There's our things you need over there. It's the usuals, something to write on, something to write with as you go. And then down here are our I cans. I can understand that decimals are equal divisions of 1 organized in groups of 10. And I can use place value knowledge to compare two numbers that both have decimal values. Reminder to keep the chat on topic for questions only. Keep the lines clear in case someone has something to ask. And let's get into it. All right, so I left this up here from yesterday because it is an important concept, this idea that decimals are essentially taking fractions, and in particular fractions to the power of 10. So our tenths, our hundredths, our thousandths, our 10,000ths, and so on till the cows come home, and applying it to our place value system, which fits really nicely because we're in that base 10 value system, where if you move over from the ones place to the tens place, for instance, it's 10 times as much, right? 10 is 10 times as much as 1. 100 is 10 times as much as 10. Okay, if you have 10 ones, we regroup them into one group of 10. Similarly, with our decimals, if you have 10 tenths, here this is the tenths place, you regroup them into one whole because, as we know, 10 tenths is an equivalent of 1. And our decimal point, our little dot down there, marks when it stops being whole numbers and starts being our equal divisions of 1, our fractions, our tenths and our hundredths, and so on. And one thing I do want to point out, because a couple people had questions on this, was noticing the placement of the decimal point. It's down here at the bottom, okay? Because we've also used a dot in math before when we're dealing with multiplication, and that one's a little bigger and it's up in the middle. Okay, this would be 1 times 23. Okay, making sure our decimal point, just like our period in writing, is down at the bottom of our line there. Okay, we don't want to get it confused with the dot that we can use for multiplication. Okay, and the reason we use that dot for multiplication is because our other multiplication symbol is an x, but once we start getting into algebra, often x gets used as a variable, meaning it's an unknown quantity. So if you have x as a variable and x as a multiplication operation in the same expression, then things can get confusing there too. So that's why we use the dot in the middle as our a substitute or an alternate multiplication symbol. The decimal point, on the other hand, goes at the bottom. All right, so just a little bit of review here. I don't remember why our 305 is up there. We're not Pitbull. Just a review here. When we're talking about decimals, just like with whole numbers, group of 10 and regroup, we're thinking about it getting groups of 10. So our whole 1 is broken down into 10 tenths, which is why our tenths place is the first one to the right of the decimal point. And then if you break each of those tenths down into 10 pieces, we end up with hundredths. Okay, if I were to draw this out, this fractions bar model, and I were to break up every single tenth into 10 pieces, 10 times 10 is 100. So each of these pieces has the value of 1 hundredth. And 100 of them, 100 hundredths, right? Numerator and denominator are the same number. That equals 1. Okay, that's why 100 hundredths equal to that whole number of 1. So in this case, we have 1 and 23 hundredths is how we would say that. Okay, couple of things just to review. Important to note when we're talking about and when we're naming decimals. When we're naming a decimal, we always name it by the last place that has some value in it. So that's why we don't say 1 and 2/10 and 3/100. We're going to group them together and say 23/100, because in fact, it's true, right? 2/10, if we multiply by 10/10, our equivalent of 1, we end up with 20/100, right? Plus those 3/100, 23/100. Okay? That can get tricky when there's some zeros in the middle. I saw a little bit of this yesterday on the exit ticket. If you have something like, let me erase my sideboard here, and we'll do a practice one here just as a review. But if you have something like, let's say we have 4 and 8/100. And we want to know what that looks like in decimal form. So we have our 4. There's our whole number. Our decimal point to mark the difference between our whole number and our divisions. Okay, and then we have 8/100. So I saw some of this on yesterday's exit ticket. Well, 4 and 8/100. What's wrong here? What place is this? Is this the hundredths? No, it's the tenths. You have accurately written 4 and 8/10. The problem with that is, what does 8/10 equal in hundredths? 10 times 10 is 100, so 8 times 10. We don't have 4 and 8/100 here. We have 4 and 80/100. So, important to remember, if we're thinking about tenths and hundredths, remembering, and it helps me often to draw my lines so I know which place is which, right? I'm going to put a T for tenths. I'm going to put an H for hundredths. Or you could put a tenth and hundredth. There's the shorthand. Just put a TH there next to it. Tenth and hundredth. If I want 8/100, I've got to put that 8 in the hundredths place. Now what do I do with the tenths place? Yeah, you need a 0 to hold that place. All right, so 4 and 8/100 would look like this, 4.08. Same thing with whole numbers, right? If you have something like 605, you can't just go, oh, well, 605. No, you need 600, 6 in the hundreds place, 5 in the ones, and then what's going to go in our tens? That 0 as a placeholder. Okay, same thing. Our zeros fill in the gaps when we don't have a full amount in that place, in that group. Okay, so really important to think about there with the tenths place. Let's get into some comparing on our digital whiteboard. Okay, so our first one here we have 38/100 or 32/100. Which one is greater? Which one is greater? Okay, and yes, we can treat this just like whole numbers. So what's greater, 38 or 32? Because we've got the same size piece going on here. They both go to here's the tenths place. So they both have 3/10. That's equal. So we've got to go to the hundredths. 8/100, it's more than 2/100. It's more by 6. So our 38/100 would be greater. Just your daily and constant reminder that the symbol, the mouth of the symbol eats the greater value. It wants the bigger portion. Okay? 38/100 is greater than 32/100. Okay? Similarly here, if we have something like, let's go with this one. 0 and 14/100 or 9/100. right? Similarly, we can, oh, hold on, I have to sneeze. Sorry. Hello. We're back. 14 hundredths or 9 hundredths. All right, just like our whole numbers, 14 is greater than 9. So 14 hundredths is greater than 9 hundredths. Right? Same size piece, same size group, whichever one has more, that's your group. Here's where it starts to get tricky. If we have something like this. We have 47 hundredths or 5 tenths. Which one is greater? And why? Let's think about this conceptually here. Okay. Often, conventional wisdom says, oh, well, I mean, 47 is greater than 5. That's a no-brainer, right? But let's think about our place value here. Okay. If we have 47 hundredths and 5 tenths, those aren't the same size piece. Okay. If we took 2 identical plates of brownies and we cut one into 100 pieces and we cut one into 10 pieces, right? We can't compare those because those pieces are different sizes. So we've got to think about, well, what can we use as a way to determine which one is greater? So let's look at the tenths place in both of these. We have 4 tenths and we have 5 tenths. Right? Automatic right there. There's your hint. Okay, which one is greater? 5 tenths or 4 tenths? Yeah, our 5 tenths is going to be greater. Right? And even those 7 ones, or the 7 hundredths, doesn't change that, right? Because don't forget, you've got 0 in the hundredths place. So it's really 50 hundredths and 47 hundredths. So we have 47 hundredths is less than 5 tenths or 50 hundredths. Okay. What if you add whole numbers into the mix? We have something like, oh, I don't know, try this one on for size. Try 3 and 12 tenths or 2 and 88 tenths. Or excuse me, 3 and 12 hundredths, yikes, or 2 and 88 hundredths. Which one is greater? Right? Just like comparing whole numbers, always start with the largest place available. In this case, it's the ones place. The last one we looked at the largest place available, which was the tenths place. Okay? Those zeros in the ones place up here in the green, those were equal. That didn't tell us anything, so we got to go to the tenths. Here, we don't even have to look at the decimal. Because which number in the ones place is greater? 3 or 2? Exactly. 3 and 12 hundredths is greater than 2 and 88 hundredths. Okay? So, today might feel a little bit reviewish and a little bit easy and comfortable. And if it does, great. If it's feeling a little bit shaky, do come to the Zoom room, which is going to open up promptly at 11 o'clock, for any feedback, questions. You want some extra practice problems with some comparisons, I'm happy to give some to you. If you want to practice multiplication or division or multi-digit subtraction or fractions, come on into the Zoom room. We'll work on it. All right? There's plenty of time and really plenty of space. On average, like between 4 and 8 kids are coming to the Zoom room. So you're going to get some pretty personalized and individualized attention if you come to the Zoom room. So hopefully I will see you there. If not, I hope that means that you're having a pretty comfortable time and you're working on it on your own, which is great. That's what great mathematicians do. Even if it's a little bit shaky, keep trying it on your own. And if you have a clarifying question, speak up and ask it. All right. Thanks for tuning in, everybody. I appreciate all of you. Have a great rest of the morning and a great lunch, and I will see you this afternoon.